This is a video from Math 386. It's on the derivative worksheet. Let's go ahead and take a look at number 1. Suppose we want to find the derivative of x to the n with respect to x. This is power rule. So this is nx raised to the n minus 1. For example, suppose I want to take the derivative of x to the 5th. In this example, what is n? N is 5. So n minus 1, if I subtract 1 on both sides, we're going to get 4. So this is 5x to the 4th. Let's take a look at number 2. Suppose I want to differentiate e to the x with respect to x. This is e to the x. For example, suppose I want to find the derivative of 4e raised to the x power. Now, 4 is constant, so I can pull that out in front of the derivative. And then I'm going to take 4 times the derivative of e to the x with respect to x. The derivative of e to the x is e to the x, right? And so we're going to get 4 times e to the x. Let's take a look at number 3. Suppose I want to find the derivative of sine of x. The derivative of sine of x is cosine of x. Number 4. Suppose I want to find the derivative of cosine x. Cosine starts with c, and so this is going to be negative sine of x. So a neat little trick is that sine of x and cosine of x come in pairs, right? Number 5. Suppose I want to find the derivative of tangent x. But we could relate that to sines and cosines. So a neat little derivation here is I'm going to differentiate sine of x divided by cosine x by the quotient rule. So the bottom function is cosine x. The derivative of the top function is cosine x minus sine of x, right? That's the top function. The derivative of the bottom function is negative sine x, right? And then I'm going to take that whole thing and divide by cosine squared x. Now, this is cosine squared x. A negative times a negative is a positive. So I'm going to add sine squared x. I'm going to divide it by cosine squared x. But cosine squared x plus sine squared x is equal to 1. And so this is 1 over, let's remind ourselves, cosine squared x. But remember, 1 over cosine x is equal to secant x, right? And so this is secant squared x. So therefore, the derivative of tangent x is equal to secant squared x. That's how we do number 5. Let's take a look at number 6. So I claim the derivative of secant x is secant x times tangent x, right? Okay, so my suggestion is relate it back to sines and cosines. The derivative of secant x is the derivative of 1 over cosine x. But this is quotient rule, right? So we're going to take the bottom times the derivative of the top, but the derivative of the top is 0, minus 1 times the derivative of the bottom, but the derivative of the bottom is negative sine of x. So I'm going to put that in red. And remember, a negative times a negative is a positive, right? And I'm going to divide by the bottom raised to the second. Okay? So this is 1 times sine of x divided by cosine x times cosine x. Now, what is 1 over cosine x? That's secant x, right? So this is secant x times sine x over cosine x is tangent x. And we derived the derivative of secant x. Let's take a look at 7, interestingly. Suppose I want the derivative of cosecant x. This is negative cosecant x multiplied by cotangent x. And the interesting thing here is I'm going to write cosecant x as the derivative of 1 over sine of x. So we're going to take the bottom, which is sine of x. We're going to multiply by the derivative of the top, minus the top, which is 1, times the derivative of the bottom, which is cosine x. I'm going to take that whole thing, and I'm going to divide by sine squared x. So this is negative 1 times cosine x divided by sine of x times itself. You know what I mean? So cosine x over sine x is cotangent x. Negative 1 over sine x is negative cosecant x. And we're good. So it's a really, really nice way to utilize the derivative of sine x and the derivative of cosine x at the same time. Okay, so let's go ahead and take a look at number 8. So the claim is that the derivative of cotangent x now starts with c. You're going to get negative cosecant squared of x. Okay? So it's just over and over and over and over again. Okay, now, the derivative of cotangent x is the derivative of cosine x divided by sine x, right? And this is just straight quotient rule. So I'm going to take the bottom, which is sine of x. I'm going to multiply by the derivative of the top, which is negative sine x, minus the top times the derivative of the bottom. I'm going to take that whole thing and I'm going to divide by sine squared x, right? So this is negative of sine squared x plus cosine squared x. So notice how I factor. Oh, excuse me. I factor out a negative out of both terms. And I'm going to divide by sine squared x. But what is sine squared x plus cosine squared x? That's 1. So I get negative 1 over sine squared x. But remember, 1 over sine of x is cosecant x, right? So negative 1 over sine squared x is negative cosecant squared x. And I'm done. So I'm going to make my conclusion here that the derivative of cotangent x is negative cosecant squared of x. And we're all set. Number 9. The derivative of b to the x is b to the x multiplied by natural log of the base, right? For example, if I want to differentiate 2 to the x, what's the base? The base is 2, right? So here, I'm going to take 2 to the x and I'm going to multiply by natural log of the base. So here, b is greater than 0, b cannot equal 1. Because when b is 1, you're taking the derivative of some constant. Number 10. Suppose I want the derivative of natural log of x. The derivative of natural log of x is 1 over x. For example, suppose I want to differentiate natural log of 5x. But this is the derivative of natural log of 5 plus the natural log of x, right? When you have the natural log of a product, you can break it up, right? The natural log of 5, if I want to differentiate a constant, you get 0. And if I want to differentiate natural log of x, I'm going to get 1 over x. Okay, so on number 11, suppose I want the derivative of log base b of x. So my claim is that's going to be 1 over x multiplied by natural log of the base. For example, suppose I want to differentiate log base 3 of x. So the base is 3, and so you get 1 over x multiplied by natural log of 3. That's basically how you do this type of question. Number 12, suppose I want to differentiate arctangent x. Okay, so here, okay, so what I'm going to do is set y equal to arctan x. This means x equals tangent y. Now, what I'm going to do is I'm going to differentiate both sides with respect to x. So this says 1 on the left side. On the right side, what's the inside function? The inside function's y. What's the outside function? Tangent of y. So inside, let's write that down. The inside is y. Outside is tangent of y. So it's the derivative of the outside evaluated at the inside. And I'm going to take that answer and I'm going to multiply by the derivative of the inside, which is y prime. So y prime is 1 over secant squared y. But this is 1 over 1 plus tangent squared y. But x is tangent y. So wherever I see an tangent y, I'm going to replace it with x. So dy dx is 1 over 1 plus x squared. Okay, so that's number 12. So let's take a look at 13. The derivative of arc sine x, inverse sine of x. This is 1 over the square root of 1 minus x squared. And then last one on the first page, number 14. The derivative of inverse cosine x starts with c, so it's negative. Okay. That'll do it for this video on the derivative worksheet. And this is for Math 386, and we did the first 14 problems. So, okay. All right, thank you.